Hey everybody, this is Larry. This is day 8 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Remove palindromic subsequence. Okay, given only A's and B's, you could remove one palindromic subsequence from S, return the minimum steps to make it empty. Okay. N is equal to 1,000. So okay, so my intuition here, and I'm solving these live, so if it's a little bit slow, fast forward or whatever you need to do. I feel like I always have to remind people to do it because a lot of people are just looking for just a solution, and that's fine. But that's not what I do here. But anyway, let's see. Right. So for this problem, oh wait, subsequence, not so subsequence makes it more interesting. Because initially I for some reason I read substring or like or just like what's it called? There's so much terminology that sometimes I get confused, but I meant just like contiguous, like next to each other. But because I saw this example where okay, you could go A B B B, then it becomes a little bit more interesting maybe. And looking at that n is equal to 1,000, a couple of things come to my mind. Which in an interview maybe is a little bit meta, but I know that n squared is going to be fast enough, but you know, now it is a little bit interesting that there's only a and b and these things. So it also reminds me of a more competitive programming problem where maybe the answer is just something weird, and by that I mean, like looking at this, I would try to think about a way to maybe because without you know, my initial misreading of the problem, where it's just substring, I would think about some sort of dynamic programming, maybe some sort of n-cube dynamic programming, something like that, like a divide and conquer dynamic program or something like that. I don't know, right? But given the n is 0 to 1,000, and then I looked at this, well, that's not this problem. So given that it is subsequence, what can we do? Okay. Can we do greedy? Right? Well, the thing to notice is that, and I don't know if this is an important fact, but I'm, you know, this is a live problem, so I'm just going through my thought process. I think one thing that I noticed is that, you know, and this is maybe obvious, but sometimes you have to put emphasis on it, which is that every character has to be removed once, right? And then the question is, okay, if every character has to be removed once, how do we combine them in an effective way, right? For instance, well, okay, now I just think about something that's really dumb, right? Which is that, okay, given that it only consists of letters A and B, you can actually remove everything in 2 steps, which is this kind of thing is the thing that I was talking about with respect to, like, I think this is like one of those annoying tricky problems. And what I mean by that is that you can do everything in 2 moves, because the first move will be remove all A's, and then the second move will be return all B's, right? Remove all B's, sorry. And if you do that, then it's going to be at least 2 moves, and also it's very easy to verify that a string of all A's and a string of all B's are palindrome. If not, then maybe pause the video and think about that. Okay, so now that we know the answer is 2, then the question is, okay, how do we, you know, so 2 is the answer no matter what, or like, sorry, 2 is the answer in the worst case no matter what, and then the question is, well, what then now you can break it down to, okay, what would give me an answer of 0, what would give me the answer of 1, and what would give me the answer of 2, right? And then, okay, the answer of S is equal to 0. I mean, for an empty string is 0, because then, you know, because you don't have to remove anything, you're done. So then the question is, and then you know that everything else is returned 2. So then the question is, how do we check if we can remove 1, right? And then this is actually pretty simple in this case, because if you can remove this in 1 step, and you can remove everything in 1 step if it's a palindrome. So, you know, and you can write this in however each way. I'm just going to write it in a one-liner, but feel free to kind of write it in, you know, a one-line if statement. This is technically, depending on how you want to do it, depending on how you want to count it, is a little bit the complexity is a little bit tricky depending on your language and how you do it and whether you create an instant of another string. Otherwise, but even the most it's not that hard to write the 2-pointer version where you have a pointer to the beginning, you have a pointer to the end, and you just kind of merge into the middle. You're in the while loop. That should be okay. The answer is accepted. Cool. And of course, this is going to be linear time because no matter what, you have to look at the string and every character of the string, and that's going to be linear time. In terms of space, like I said, you can have 2 pointers to count the palindrome. This is a very basic problem. Or you do what I do, which is kind of maybe overend space, depending on how the language implements it. But I'm just kind of, because I'm focusing on the explanation and hopefully the thought process, and versus on all the details for now. And of course, like I said, you should be able to solve this at home by making it over one space. But yeah, I don't think this problem is tricky. Oh, sorry, I don't think I have anything. I mean, this problem is tricky, but I don't think I have anything tricky to explain after I know the solution. Like before, it's one of those trick problems where if you know the trick, then actually it's duh. If you didn't know the trick, then and hopefully you saw how I did it. I kind of thought went through different processes and maybe even a misreading. But yeah, after you see all that, after hopefully when you see my explanation or like my live explanation, because I thought about this live, now that looking back, I feel like I've solved this problem before, but I still didn't recognize this off the bat because this is such a one-off, right? Like if you memorize this problem, then it's not a waste. It's not a good use of my memory to memorize these problems. So even though it feels familiar, I don't remember the solution. But that said, hopefully the way that I thought about it gave you some insight on how to solve this for yourself. Cool. That's all I have. It's a fun, silly problem, but it's cute. Probably not gonna see this in an interview, or at least, well, maybe not by itself. Maybe you could see like 2 or 3 problems in like a session and then do it, or forced to do it, because it's such a it's such a weird interview question, because it's like if I were to ask you this problem, it's like either you know it or you don't, and I don't know how much it teaches me about you as a candidate. So that's why I wouldn't give this problem, but who knows anymore. Everyone asks a lot of questions, a lot of interview questions that I disagree with. So anyway, that's all I have. Stay safe, stay cool, stay healthy, and to good mental health. I'll see you tomorrow. Bye bye.